In this section, I'll dive into Azure Storage, which in a way is a collection of different ways to store your data, from blobs over queues to table storage. More or less every way you can imagine, except for storing your data in a typical relational SQL Azure database. That's for the next section. I'll start by detailing Azure Storage, focusing at a high level on what it is and why you'd want to use it. Then you will learn how to create a storage account, how to work with it from the Azure portal, and how to connect to it. You will learn how to work with Azure Table Storage, Azure Blob Storage, and Azure Queue Storage, using a variety of techniques, from the REST API over the Azure CLI to the different .NET integration libraries that are offered by Microsoft. Let's dive in. So, what is Azure Storage exactly? It's a cloud storage solution. That means that it offers the typical things you can expect from cloud-based services, just like we already learned about with App Service. There's high availability, replication, automatic or not, scalability. It's secure. Everything at rest is encrypted. And as Azure Storage is a managed platform as a service, things like maintenance, software updates, and so on are handled by Azure. There's a variety of ways to manage the data stored on Azure Data Storage. As you would expect, you can manage it directly on the Azure portal or via scripts, executed via PowerShell commands or via the Azure CLI. But as it's about data storage, your applications that need to manage that data need access to it as well. A REST API exists, but more likely you will want to use one of the various client libraries for integrating with Azure Storage. Libraries exist for .NET, Java, JavaScript, Python, and so on. We will integrate with it from our demo API using the .NET client library. But there's more. Another popular option for viewing and managing data in Azure Storage is the Azure Storage Explorer. We will use it soon. You can look at it as the low-key alternative to a full-on SQL Server Management Studio, but for Azure Storage, because Azure Storage is not about relational databases. That's what Azure SQL is for, which is covered in the next section. So, what type of data is handled by Azure Storage then? We're looking at Microsoft's Storage Introduction documentation. You can find it via the URL on screen. It contains a nice table with a bunch of sample scenarios for the different types of Azure Storage services. Let's expand that table so we can have a look. The one down here, Azure Tables or Azure Table Storage, is one of the most important ones. It's a service for storing non-relational structured data. So no SQL data without a schema being involved. It's optimized for dealing with large amounts of unstructured data. If we scroll back up, we find Azure Blobs or Blob Storage. This is used for storing typically larger amounts of text and binary data. Think about images, documents, audio and video streaming, and so on. Those are typical use cases for blob storage. And if you scroll down again, we find Azure Queues or Azure Queue Storage. This is a message store on which you can store messages that can then be picked up for async processing later on. There's more Azure Storage services, all with their specific use cases. These services are file storage for managing file shares, Elastic SAN for working with storage area networks, Azure Disks or Managed Disks, and Azure Container Storage. But as a developer, the ones you are most likely to run into are Table Storage, Blob Storage, and Queue Storage. So those are the ones I will detail in this section. But first things first. For all of these you will need a storage account. Let's look into that next. All these storage objects like blobs, files, queues and so on, they need to be stored somewhere in a storage account. This provides a unique namespace for your Azure storage data that's accessible over HTTP and HTTPS. Just like many things in Azure, storage accounts come in different flavors. You're looking at those right now. Let me expand this table a bit. It's coming from Microsoft's documentation. You can find it via the link on screen. First up, a standard general purpose storage account. It can be used for blobs files, queues and tables, and it's the most common one recommended for most scenarios. If you're only dealing with blobs and need higher transaction rates or need smaller objects with consistently low latency, go for the premium block blobs type. For file shares that need to support SMB and NFS, go for the premium file share type. And if you purely need page blobs, consider the premium page blobs type. But anyway, the standard general purpose storage account is the best fit for most scenarios, so that's the one we will use. Be careful though. Consider in advance what you will use the storage account for, because you cannot change a storage account to a different type after it has been created. You will have to copy over your current data to the new storage account if you want to use another type. Let's switch to the portal to create our storage account. Let's click Create a Resource. And let me look for storage account. And let me select Azure Services Only here. This immediately gets me to Microsoft's storage account. Let's click it. And let's click Create. All right, just as with the app service, we need to provide a few details. I'm going to use this one for our travel inspiration scenario. So I would prefer to name it something along the lines of appdev st for storage account dev we travel inspiration. But as you can read, that is not allowed. A storage account must be between 3 and 24 characters, and it can only contain lowercase characters and numbers. So I cannot follow the best practice naming convention approach previously decided on. I'm personally not a big fan of this, but it is what it is, I'm afraid. I am going to create it in the Travel Inspiration resource group, of course, and let's name it something that is allowed. Say appdev st without hyphen dev we travel, because otherwise it's more than 24 characters, and that one is allowed. I'm going to create it in the West Europe region. Standard performance is okay. Geo-redundant storage, which is also the standard, is also okay. So we'll leave everything else at its default. Then, if we wish, we can configure some advanced options, like our own endpoint naming if we wish. We can also define some additional networking options, like if the endpoints are publicly accessible or not. Data protection, like whether you prefer a soft delete instead of a hard delete. The encryption keys, as storage is encrypted as REST. And of course, tags can also be configured. For the demo, we don't need to configure anything of this. The default values are fine. Let's click Review and Create. This is looking good. And then let's create our storage account. And there we go. Deployment is complete. Let's have a look. Here's our storage account. As mentioned, you can use the portal to manage the data that's inside of this storage account. On the left here, you can find the storage browser. Let's click that. This gives us access to the containers. Containers contain blobs. It also gives us access to the queues, which contain messages, and it also gives us access to the tables used for table storage. Or you can also directly navigate to those blades via the data storage menu option here. So containers will bring us to the containers. Queues will bring us to the queues, tables will bring us to the tables. These blades allow you to manage the structure of your container or table, but they do not allow you to manage the data. I'm going to go back to the storage browser here. That one does allow that. And let's see what we can do. I'm going to start with table storage. The first thing to do here is adding a table. For the demo, I'm going to make sure that the destination search feature, which currently gets its data from a list of hard-coded destinations, will now get its destination data from table storage. So let me add a destinations table. And let's make this a little bit bigger. There we go. Let's click it. And from here we can now add data to it. Let's choose to add a new entity. By default, a partition key and a row key need to be inputted. I'm going to add two more properties, things we can use in our demo. Let's start with the identifier. This will become the unique key of our entity, of our destination. Theoretically, you could use a row key for that, let's say, but you don't want to use one of these internal keys, so not the partition key either, because they might change if, for one reason or another, you need to move to another storage account. Or say you need to export and re-import data at a certain time. You have no guarantee that these row keys and partition keys will remain the same. If you add your own application level identifier, let's say, you are sure that it will remain the same. And let's add another property, name. Well, let's fill out a few values. Let's start with Antwerp, Belgium. Let's click insert and let's add two more. San Francisco, USA, and another one, say Sydney, Australia. By the way, in this scenario, all entities have the same amount of fields, but table storage doesn't require this. It's non-structured data, so they don't have to have the same amount of fields. Each entity can have different fields if needed. You may also notice that I didn't add the image name here. If we have a look at the code base, we see that next to an ID and a name, there is an image name. But I specifically do not want to add that one to our table storage entity. That's because later on in this section, we're going to use blob storage to store that image. Then we will revisit this. That's it for adding the data. Now, how can I access this data? Let's continue with that